don't know what they do. Set the projector to something else. What are they looking at? Anyways, okay. So we've been on chapter 7. So I better upload the quiz for chapter 7. Make sure it's not corrupted. I'll do that pretty quickly. I'm not expecting people to do a lot of stuff over Thanksgiving break, although I bet people hopefully will be looking at their projects. So chapter 7 was over using methods. Chapter 8 is called Advanced Method Concepts. We've already been doing these advanced method concepts, which is why we hung out on chapter 7 for a while. For example, using ref, using out, overloading methods. Learn how to avoid ambiguous methods. Well, we didn't talk about that. And optional parameters. We've already done all of that if by optional parameters they mean default values. So a mandatory parameter is just one that's required, right? Function D takes parameter P. You always have to fill it in. You can create reference parameters. You can create output parameters. Or you can create parameter arrays, which is about one of the only important things in here. Well, I mean, it's all important, but we've already talked about it. We have skipped that. What would you do with a parameter array? You make it where you can pass in variable numbers of parameters. You want to pass in one thing, you want to pass in two things, you want to pass in three things. Just like when you use placeholders in your write line statement, you're passing in multiple parameters, right, separated by commas. You can pass in as many as you want. The reason why that works is they get converted into a parameter array. And we will get back to that topic. So, in an optional parameter is one that's declared with default values. A value parameter is the one that you get by default. It gets a copy of the value because C# by default is a pass by copy, a pass by value language. However, it also supports these out and ref, and the newer versions even have one called in. Ref allows the method to change the data. Out allows it not to pass data in, but it allows it to be changed to be passed back out. If you pass in something as ref, then whatever you passed in can be used, and then it can be modified. But without, it must be modified, or else the method won't even compile. All right, so I'd rather zip ahead to chapter 9 and then come back to parameter arrays. Ooh-wee, don't I have a lot of these? Using classes and objects. We're going to learn about class concepts. We're going to create objects. We're going to create properties. This is C# specific stuff that is not available in Java, and it's pretty cool. Learn about using public and private. If you've ever done any object-oriented programming in Java or C++, you're familiar with those terms. And the this reference. The same is true of that as well. It's possible some of y'all are taking this without having taken Intro to Java, so I'm not going to just be able to go, oh, you know what public is. But I believe a lot of y'all have. Okay, so this is a class is a group. All right. I certainly wouldn't have defined it like that. My definition is a class is a blueprint, and I know some of y'all have heard this a million times, for a collection of data, or you could just say for data, and the methods that act on that data, or that use that data. It's a blueprint for an object, that contains data, and the methods that use that data. I better start making my notepad file so I can add this to the notes. And then an object is an instance of that class, right? So you can make a person class, and the person will have some pieces of information. A person can contain a name, and a person can contain, an address. Then you might make a person object, person P1. That's not the syntax for making it, but P1 has its own name, Bob, right? And its own address. P1.address is, 123 South Main. And then you could create another instance of it, person P2. Now the correct syntax for creating the object is this, person P1 equals new person, like that. If you've done C++ programming, please note that you're not allowed to create an object just by doing that. You actually have to create the object itself by doing that. And then we're going to make another person equals new person. And then P2.name equals, Joe, and so on. So this creating of an object is called an instance. This is an object. Instance, it's an object, so it's called instantiation. We're going to instantiate the object. If I ever get fancy and say instantiate, I just mean make a new one. This is what's known as a reference variable. It's not the object itself, but it's real easy to say, yeah, P1 is a person object. Well, it's really not a person object, just like an address. I live on 123 South Main. Is not a house, right? It's the address of a house. P1 is the address of a person object. So when this goes out to memory and allocates memory to hold that person object, the address is stored in a P1. Same here, right? So it's an instance. It's a reference to an object. And here this creates another instance. So the new keyword creates a new object in memory and then assigns a reference to the reference variable of that type. That's almost too techy, but P1 is a reference variable. It's of type person, and it contains a reference to a new person object. So classes are the building objects, the building blocks of object-oriented programming. That's very true, because each thing that you draw on the screen, a button is an object. Why is that? Because a button has a position. It's got an X position, a Y position. It's got a foreground color, a background color. It's got a border. It's got whether it's enabled or disabled. All of those are pieces of information that are contained in the button object. There are lots and lots and lots of classes built in to the language. So for example, double with a capital D, int32 with a capital I, and float with a capital F are all classes. So any number declared as one of these classes can be used in arithmetic or converted to a string just like it was a primitive value. They just have more capabilities. So types of classes. Classes that are an application program have a main method. And then you can have classes from which you instantiate objects. This says that they can contain a method, but a main method, but that's not required. Usually they don't. Usually you have one class with your main method, and then you have some data classes. Where'd that word every come from? Did I add that accidentally? Yeah. So let's go do that. Let's make a new project, which I've already done, so catch up. Now one school of thought is you could put every class in its own file. That's a Java rule of thumb. But since we have this namespace here to differentiate our things, we could just put all these classes in the same namespace as long as they're related. So we're going to make a person class that has a first name and a last name, and then maybe an address. So class person. It's going to have two pieces of data. A string that's a first name. I'm just going to call it first, make it easier to type. String last. Apparently I can never spell the word string. And down in main, I'm going to create a person. Person P1. Is that enough? I said that it's not enough. Yeah, it's not enough. Person P1 equals new person. Now in Java, all the members of a class are public by default, or something very close to public, called package level, instead of being private. But in this language, they are private by default, so I can't change those pieces of data from out here. I can't access them. I can't type in p1.first, which at this point is what I want to be able to do. We'll change this later, but for now, I want to be able to say public string first and public string last. Now in C++, when you declare an access level, you put a colon after it, and then everything listed after, don't do this, everything listed after it is public. Nah, this is more like Java where you have to specify the access level for each member. Now that I've done that, now that these are public, I can access those pieces of data down here in the main method. You could call this a client code. It's the client of the class, or some textbooks call it the driver. I don't recall which one this textbook uses. We'll find out pretty soon. So P1 dot first equals, Susan, in quote, and P1 dot last, I'm getting an underline there and I'm not sure why, is equal to Anthony. What are you griping about? Okay, it fixed the errors on its own. I love those errors that hang on after. Well, I guess it can't instantaneously recompile the whole thing, every letter you type. So sometimes the errors lag behind, the error detection lags behind what you've just typed. So we have, here I'm going to use the incorrect terminology. We have a P1 object of type person. It's really a reference to an object. And we've got two what are known as instance variables. Why are they called instance variables? Because P2, if we made one, could have different values for it, right? George Washington, right? Different information, so they differ on an instance by instance basis. P1 is an instance, or it refers to an instance. I'm going to stop being picky like that, and I'm just going to say P1 is an instance. P1 is an object, it's an instance, and it's got these instance variables, and then if we create another one, we could assign different data to it. Person P2 is equal to new person. And then P2 dot first equals George. And P2 dot last equals Washington. Now what if we turned around and did this? P2 equals new person. I'm probably going to comment that out. But now we have an object with no references to it, right? This ran out in memory and it created an object to hold all that data. But then we created another person and set the same variable pointing to that new place. It's like creating a brand new house and assigning it the same street address. Well, now we have an old house with no street address whatsoever. Maybe that's a silly way of thinking of it. But we have an object with nothing pointing to it anymore after we do that. That's called an orphaned object. And in C++, that's a very bad thing because it wastes memory. Something needs to come up and delete these things. C# along with Java and Python have something known as a garbage collector. So when there is nothing, no variables that are referencing that object anymore, the garbage collector comes and frees it. So this object that has the data George Washington will eventually just disappear from memory completely, and now we have a new object that could store different values. But I really don't want to mess with that idea right now, so I'm going to delete that line. So I said that a class is a collection, well, it's a blueprint for a collection of data and the methods that act on it. Well, we don't have any methods yet. Let's make one. Public full or get full name. And this language, unlike a lot of others, they really like our methods to begin with uppercase letters. I guess I will try to abide by that. And what does get full name do? It returns, and by the way, I have an error already. It return, I'm not going to put the word S there, return first plus a space plus a last. Now since it's returning a string, that's its return type. So public string, get full name. So down here, after I create P1 and P2, I'm going to print them out by calling the get full name method. So I created object P1. I'm going to print it out. CW tab P1 dot get full name. Parentheses and parentheses because it is a method. Eventually, we're going to learn how to make it so that get full name doesn't look like a method. You just print out P1 dot full name. Even though we don't have a full name instance variable up here, this will work if we take it that far. But right now it's a method. That's called a property, by the way. And I could print out Mr. Washington too. P2 dot, CW tab P2 dot get full name. Parentheses and parentheses and parentheses semicolon. And since I forgot my read line at the bottom, it's running and closing the window. Console.readline, parentheses and parentheses. All right, and printed out our two pieces of information. You can do a lot more with objects than just create containers full of data and methods that act upon them. But that's a good start. That's the concept. The object is a blueprint for something that's got a first name and a last name and a get full name method that uses it. A good precept of object-oriented programming is to make your data private and your methods public. If we make these things private, I'm just going to do it to one of them to demonstrate, and then I'll probably undo it. If we make them private instead, then these references to P1.first no longer work. If we wanted it to work, we'd have to do two things. One is we'd have to implement a property that reflected that variable, or we'd at least have to provide a setter or a mutator. Skip that for now and go back to the PowerPoint. So I'm going to change that back to public. So the instance variables are sometimes called fields. So this thing has two fields. Oopsie, not that thing. This thing has two fields. Those are the object attributes. Those are the data components of a class. And the sum total of all those fields is called its state. That's the state of the object. The state of this object is that it has a first name and a last name, right, of Susan and Anthony. That's its current state. There's a concept of synchronizing state. You could write all your state information out to a file, and then later on you could read it back in, right? And so you've recreated the state of that object by reading from a file. So the instance variables hold the data components of a class that differ for each object. You can also have a data component that's shared between all objects. That's called a static variable. So an instance method is the method that's associated with the object. And every instance of the class has the same methods. Since P1 has a getFullName method, so does P2. There's no way to create a person that doesn't have a getFullName method. And then the client class, or the user. Okay, I said that some people call it a driver. Apparently this textbook likes the term user. So the user of the class is the main method in this case. But you can have a class which uses a class which uses another class. In other words, you can have a class that's a client of another class which is a client of another class. And that program instantiates objects of another class in order to use it. Just like main uses the person class. It instantiates two person objects. So you can have an optional access modifier. I don't really consider it optional. Public, protected, internal, and private. I swear we saw these when we were talking about methods as well. Yeah, so public means it's accessible by anything. Protected means that it's accessible to only to methods inside that class, and to classes that inherit from it. Private means only available inside that class. Not even inherited classes, child classes, subclasses can access that data. And then there's internal, which I never remember because it's not available to us in a lot of other languages. So public is access to the class is not limited. In other words, anybody who knows the name of the object and the name of that field can get a hold of it. And when I say anyone, I mean the code. Protected, access is limited to the class and any classes derived from it. Internal, access is limited to the assembly to which the class belongs. The assembly is a group of code modules compiled together. That pretty much sounds like public. So the .exe files you create after compiling a C# program are assemblies. Internal and public sound very, very similar to me. And then private. Access is limited only to the class in which it belongs, not even derived classes. So here's our employee class, and it's got one field, which is a private variable. Most of the time, your data is going to be private and it's going to be non-static. You would tack the word static on here if you wanted it to apply to all objects of that class. If you wanted everybody who was created to have the same last name or the same ID number, you'd add the static keyword there. Now that sounds silly. You don't use the static keyword very often. A good rule of object-oriented design is to go ahead and make it private. Or if you're creating classes that inherit from it, derived classes, you could waffle on whether you want to make it private or protected. Private data is only modifiable by that class, accessible by that class, but protected data is also accessible to the inherited classes, the derived classes, and that could be useful. So using private within classes is an example of information hiding. Usually you make your class methods public. What does information hiding mean? Other textbooks call it encapsulation. Encapsulation means that the client code, the driver code, the user code doesn't know internally how that data is stored or even what those fields are called. All they know are the methods, the public methods that can access that data. Composition is using an object within another object, which is a has-a relationship. Every person has a first name. Every person has a last name. Composition. Objects using other objects. This is a has-a relationship. Now a string actually is an object, so I feel pretty comfortable about saying that first is an object and the last is an object, even though we don't think about them that way. So, person has a first name and a last name. There's also the is-a relationship, and that's when you derive classes. That's when you use inheritance. You can make an employee who is a person. In other words, they are derived from the person class. You could make, a customer who is a person. So you make a customer class that is derived from the person class. No, apparently I've done something very wrong, and I can't compile anymore. That was not my intention. All right. So, right now, they've got this class. It's got a piece of data that's private. It's got a method that uses it. Welcome from employee whoever. Well, there's no way to set that data. So it's an incomplete class. We need to provide some way to set that data, to change it, to mutate it. That could be called a mutator or a setter. So declaring a class does not create any objects. Just because I declared my person class here, that never made an object. It didn't allocate any memory. It's only when I actually create, when I instantiate it, that that memory is locked down to create a new person, create a new object. So we declare a reference to the object. That's stage 1, just like that. That's the variable. You specify the object, the class, and then the name, the identifier, and then you create the object itself using the new keyword, which allocates some memory for it, but they're not telling us the whole story. That creates the object, but that's not enough, right? You make a new employee, you don't have a variable towards it, pointing towards it, the garbage collector is going to delete it immediately. Instead, you'll also have to assign the reference to that object to the variable that you created, or else you lose track of your object. So when you create an object, you call its constructor. Well, what's a constructor? It's a method that has the same name as the class, and it's accessed by the new keyword. So let's make a constructor. I'm going to make it public because otherwise you wouldn't really be able to create it. It's got the same name as the class. It does not have a return type. It can have parameter variables. This one doesn't so far. And it's just going to set this dot first equal to default, and this dot last equal to default, just to be doing something. Right? If it wasn't doing anything, then why write the constructor? But we could write a constructor that actually sets those variables. Just like they could write a constructor, and I hope that's the next slide, that sets the ID. Nope, not yet. Still not yet. Oh, forget it. We'll do it ourselves. We're going to make a constructor that sets the first and the last name. If it doesn't take any arguments, you can call it a default constructor. That's close enough to the truth. Honestly, the default constructor is the one that C# gives you if you do not provide any constructors at all. But it's one that doesn't accept any arguments, so that's close enough. You can call it the default constructor. We're going to make a non-default constructor, which allows us to pass in the first and the last names. So public, person, but it's going to accept 2 strings. String first, comma, string last. And if you've done Java programming, this looks, or Python programming, this looks incredibly familiar. This dot first equals first, and this dot last equals last. Now, why are we using the this keyword? We honestly did not have to use this up here. I could delete the this keyword up here. I don't recommend you do, but it would still compile, because it knows that since there's no local variable or parameter named first, then it has to be a member of the object. But here we have 2 things with the same name, right? And so if we just had first equals first, that'd be silly. It would be assigning that parameter variable to itself. So we have to specify, no, this particular thing is a member of this object. That's where the this keyword comes from. So that's what we use that for. And I like typing this anyways, even when it's not necessary, because it pops up a handy list of all the members. This dot, right? And then I could type in first or last or whatever. So in general, I always use the this reference even where it's not necessary. If you see other people writing code and they leave the this reference off, it works just as well. It could be that the only things that have to use the this reference are the setters, or the constructors, like this, where we're passing in parameters with the same name. If these were passed in with a different name, we wouldn't have to use this, right? If I just made this string S1 and string S2, right, then I'd be able to get rid of the this reference, because now there were no name collisions, right? No confusion about what first means. Just go with it. Just use this. So now we can create a person using a constructor. And since we can do that, we no longer need to allow the calling code to access those fields directly. We could go and make them private. That's going to break the code temporarily, but that's okay. I'm going to come up here and make these things private. Rule of thumb, class rules of thumb. 1, data private. 2, methods public. 3, add a constructor if it makes the class easier to use. All right, now that I made those two fields private, the code's broken. I can see the red arrows down here. We can no longer access those fields. We could comment them out. We could delete them. I'm just going to comment them out. But how am I going to get that data in there? I'm going to use the constructor. We created a custom constructor, a parameterized constructor that allows us to pass in the first and the last name. So new person, Susan, end quote, comma, quote, Anthony, end quote. Same business down here. I can't access those fields directly because they're private, so I'm going to pass them into the constructor. George, end quote, comma, Washington. So why do you want to do data hiding like that? Why do you want to do encapsulation? One reason is that you can validate the data. Make sure that it's good. If I could do this, p2.last equals empty, like that. I mean, that might be good for Madonna or Cher, you know, I mean, anybody with only one name. But really, we don't want our database to allow anybody to have no last name. That should not work. So we can make a setter that checked, and if you're passing in a last name that's blank, it rejects it. Won't allow you to create that object or, you know, write it to the database or whatever. Your goal is to try to make your object always have good data, to not get into a bad state. And so your setters can be validating the data as you do that. You know, this creator here, I'm not sure what I would make it do if I tried to pass in bad data, but it certainly should not allow us to do that. That's a question I'm going to have to think about, how to make that. One thing you can do is to make it throw an exception if you pass in bad data. We haven't done exception handling, so I'm not going to talk too much about that. All right, so now it should work the same way as it did before. It should print out their first and the last names. So you can pass objects to methods just like you can any other piece of data. We could make some kind of print. Don't know why I have this here, clicking down the time. We could make some kind of print method inside the main class that would print out our person. It would accept a person. So static void print, parentheses, and it needs to accept a person, so I'm going to say person P. Good enough. And so console CW tab person colon first equals curly brace 0 in curly brace, last equals curly brace 1 in curly brace, end quote, comma. And we don't have a way to get that information out. We don't have a way of getting the first and the last name out individually because we did not provide getters and they're private. So instead, let's nuke all that and just make it say full name equals end quote plus p dot get full name parentheses in parentheses in parentheses semicolon. So that method will accept an object of that type. We may not even want to run it like that. There's nothing wrong with running it like that, but after we create our two variables, right, we could come down here and print them. Print P1, print P2. And there we go, right? So we passed a reference to that object in. And I know I mentioned this in our prior lectures, but it's more efficient to pass it in by reference. And why do I say that? Because if we pass it in by copy, it has to copy all this information. George and Washington, it's creating a new object in order to hold all that stuff. Instead, we're going to pass it in by reference. I don't know. I could leave that out for now since it's not talking about it. But if I was going to, I would add ref there, which means I have to add ref here and ref here. I'm going to undo that. I'm not digging it. Let's leave that topic alone for now. But if you are going to use references, if it's not going to change it, if you're using references for speed, you should make it a constant parameter variable, which guarantees that your class, excuse me, your method is not changing it. Because if people see the word ref up here, they can get worried that your method that you've written has a possibility of changing the data. All right, we need to kind of get close to wrapping up. Creating properties. This is where things get interesting and get completely different from Java. Let's add one property. But we never created getters and setters for first name and last name. That's all right. We'll do it for age. Int age. And we're going to make two methods, a getter and a setter. Void set age, that accepts age as a parameter, and it sets this dot age equal to age. And we're going to provide another one called get age. Since age is an int, it needs to return that. Int get age, but it doesn't accept any parameters. And it returns this dot age. All right, that's one way to do it. That's how we've done it in every other language. So if we wanted to set the age or get the age, we could do that. Right? We could just run down here. And after we've made George Washington, he's pretty old. So, you know, p2.setAge, you know, he's about 239 years old now. Whatever. Right, okay, I'm going to not make it so stupid. He's 39 years old. It's complaining because I did not make those methods public. So I'm going to scroll back up to my class and make those public. And I'm going to make age, int age, private. So public void set age, public void get age, private int age. Now that's a classic way of doing data encapsulation. You make a variable and you provide a getter and a setter for it. Why are you underlining? Oh, because I tacked on the word void there for some reason. Public void set age, public int get age. But this slide here is showing us a new way of doing it, where you declare a variable. It looks like a variable, but it's actually a method that's got two sub-methods listed in it, a get and a set. And so you can give it the same name as the variable itself, but with a capital letter in front of it is their recommendation usually. So int age capital, and it's going to have a getter and a setter. So I don't botch it, I'm going to go back and look at the PowerPoint again. The getter returns the variable, and the setter sets that variable to this magic keyword called value. That magic keyword is just something that C# gives you. It serves the same purpose as that. So let's do the getter. Get, it's not even really a method, so it doesn't have any parentheses. And it returns this dot age. And the setter sets the age. So this dot age equals value. And like I said, value is a magic keyword that they give us, which serves the purpose of this variable that we always pass in our setters. I wouldn't have minded it if they made us have to do this, right? Set value, right? Like that or something like that, but they didn't. So this is a property that reflects, that exposes the age field. And I bet it's supposed to be public. I bet I skipped typing that in if I go back and look here. Yep. So the tradition is to make your fields begin with a lowercase letter, and then to make your properties that expose them, that reflect them, begin with an uppercase letter, just so you can distinguish them. Now when I'm ready to use it, the syntax is easier. I don't have to do this. I don't have to say P2 set age 39. I could just do P2.age equals 39. Or if I want to get the age out, P2.age, I have two ways of doing it. Get age, the old primitive way, or the new way. That's giving me grief. Nope, finally fixed it. P2.age like that. So there's nothing wrong with doing it that way. It'll kind of expose your roots as being a Java programmer if you do it that way, or a Python programmer, somebody from some other discipline. Nothing wrong with that. That's pretty cool though, because you can make your getters and your setters still do all the validation that they need to do. If age cannot be negative, then you might make the setter check. And if they're passing in a negative age, you could set an exception, or you could just set the age equal to 0, print out some error message, something like that. So, rules for properties. He says we start them now. The field, the variable, should begin with a lowercase letter. The property that reveals it, exposes it, reflects it. And I'm going to add the word the private field should begin with the lowercase letter. The public property that exposes that field should begin with uppercase. The property has a get and set. Leave off the set if it's supposed to be read-only. You may have some field that you don't want your calling code to be able to set, in which case you just leave off the setter. I could do that. I could come up here and comment out the setter here. Our code would no longer compile, right, because we have something here that's calling the set, but this line would work because that's a read. So this calls the properties get and set, and this calls the properties get. Okay, so the homework for this, I think I'm just going to have you write a book class. The book has several members. Title, author, publisher, and pub date. Make them all strings if you want. Or you can make pub date an int, either way. So rather than add getters and setters, add properties. In other words, title with a capital T, author with a capital T, publisher with a capital P, and pub date with a capital P. Add get and set for every property. main should create 2 different books. And print their data using the properties. And when I say private members, I'm going to call them fields. So instead of the term member, I guess I'll say instance variables, trying to reflect the terminology the book uses as closely as possible. Okay. This doesn't have a constructor. If you feel like adding a constructor, great, but I really want you to exercise the properties. So main should create 2 different books using the properties to set the data and to print the data. In other words, you're not going to have any getters and setters. So don't add any get title and set title methods, etc. No accessors and mutators. I think I'm going to delete that because it's making a little bit confusing. The key thing, and the thing that I'll make bold-faced when actually posted as a homework assignment, is properties. So you should be able to do something like this. Book B1 equals new book. B1 dot title equals Harry Potter and the Temple of Doom. It's crossover. And then B1 dot title equals, you know, J.K. Rowling, etc. Makes sense? Okay. Once we have these objects, we could save them to a list or put them in an array, or do something useful like that. And the next thing that comes up is we will be adding constructors and stuff like that. But I want this to be a simple introduction to it. All right. Any questions?